Create a 3-axis flat toolpath. After completing this video, you'll be able to use flat and create a toolpath to identify flat areas. In Fusion 360, let's carry on with our 3-axis sample. At this point, we've essentially got two operations. We have a 3D adaptive to remove the majority of our stock, and then we have a 3D parallel that's done a lot of finishing. There are a couple of other toolpaths that we do want to explore, and on this side, there's one more that we want to take a look at. But first, let's remember that inside of 3D adaptive, we had a flat area detection option. Because we left stock behind, it was not able to finish off the flat areas of our part. However, it did go into those flat areas and identify them, such as this bottom section. Inside of our dropdown for our 3D tools, there are two main tools that can be used for flat area detection. There's a flat toolpath and there's a horizontal toolpath. There are a couple of differences between these, but in this example, we're going to explore the flat toolpath. This has a couple of extra options, such as using a pocket or parallel strategy inside of it. When we select flat, the first thing we need to do, just like any other toolpath, is select the appropriate tool. For this, we're going to be using a 1/4" flat end mill and selecting. Next, we're going to move on to our geometry, and for this, we're not going to make any selection. Our machining boundary by default is none, and I'm going to leave that turned off. In the passes section, we're going to take a look at some of the options we have. Our passes look slightly different for this flat toolpath. The main option I want to focus on is the type, allowing us to use a pocketing finishing strategy or a parallel finishing strategy. The pocket strategy is going to be the most efficient for our geometry because it's going to come into this pocket area and allow us to create a 2D contour along the edge and finish off the floor. The step over amount right now is 0.25, which is the entire diameter of our tool, and it's probably a bit much, so I'm going to change this to 0.125. There's also some smoothing deviation options, and for our case, because we have straight edges, it's really not going to make too much of a difference. We're going to leave the profile cut direction on climb, and we're going to add a finishing pass. There is a finishing step over amount, and this is generally used for finishing walls. At this point, let's say OK and allow it to generate the toolpath and see where it's cutting. I'm going to use F7 to bring back our toolpath preview, and we can see that it's cutting this top section here, as well as this bottom area. When we take a look at this toolpath, this looks like an efficient means to finishing off these flat areas and these walls, and it's something we could omit from previous toolpaths such as our parallel. But let's go back into our flat and let's take another look. In our geometry section, we can also use avoid touch surfaces and allow it to avoid or select specific areas to work on. We do also have a rest machining option, which will take a look at material that's used from previous operations. If we say OK, it's going to take a look at material that's already been removed and determine whether or not it needs to machine certain areas. It's taking a little bit longer to calculate, but because we already did our parallel strategy to finish these top faces, you can see that it does avoid finishing those. However, because we are going to be flipping this part over and resting it on parallels, I want to use this flat strategy to finish off those areas. So I am going to right click and edit this toolpath again, and this time I'm going to disable rest machining. We're going to say OK and allow it to regenerate those toolpaths. Next, I'm going to go back into my parallel strategy, and under my geometry, under avoid touch surfaces, I'm going to avoid these top two faces, and I'm going to allow my flat strategy to finish those off specifically. We can now see that the ball mill is stopping short of that edge. We do allow it to contact the boundary with the center of the tool, but it is not going to be machining those top faces. Then our flat toolpath comes back and does a finishing pass on those. For this specific part, remember that we are using 1x2 stock and we're not cutting below the top, so we ultimately will have the same geometry that we had with the initial rough stock. But keep in mind that for this part, that's not really a concern or a consideration that we need to make. The main thing that we want to do is we want to identify toolpaths and their uses for different types of geometry. At this point, the 3D adaptive removed the majority of the material, and we used a couple of 3D contour toolpaths to explore whether or not they were viable for this part. Ultimately, we used a parallel strategy moving along the X direction, and then a flat strategy to finish off those flat areas. At this point, let's make sure that we do activate to go back to our named view, and let's go ahead and save the design before moving on to the next step.